Okay, on the wise bottom, but that's fine. What was I gonna say? Oh yeah. So I hope everyone's March break went well. Ish. Hope you're well rested ish. Probably hard to wake up again this morning. But we get to start fresh, okay? New unit. It still has to do with like quadratics, but less about like kind of like factoring and FOIL, and more into like the graphs and what they kind of look like and how we can graph quadratic equations. Okay, so linear relations. We're gonna do this for our next unit. But remember from like grade 9, the formula is y equals mx plus b. Okay, so it's what we call a first degree polynomial because our x has an exponent of there it is. Has an exponent of 1. Okay. So we're going to be discussing these more in our next unit. So if you were to graph out y equals 2x minus 3, you have a slope of 2, and the y-intercept is at right here, which is negative 3. Okay, so get a lot more into solving these next unit. We just want to kind of talk about it a little bit because we're going to be comparing a lot between the two. Okay, so we'll go through quadratics and we'll compare to linear. And we'll go through linear and we'll kind of compare back. Okay, so for this one, we're going to talk about quadratic relations. Okay, so a quadratic relation is an equation determined by a second degree polynomial. Okay, so it's going to have a square. Yeah, it's one page double-sided, then a single-sided page. We probably won't get through the whole thing today.
No way. Yes.
Yeah. Okay. So the general equation, instead of y equals mx plus b, what we have for quadratics is y equals a times bracket x minus h squared plus k. Okay? This is what we call vertex form. And we'll get a little bit more into what the vertex of a quadratic is later on in this lesson, okay? So if we have y equals 2 minus 3 all squared plus 4, it's going to look something like this, okay? It'll have the shape where it almost looks like a U. Starts up, comes down, and goes back up. And these ends keep going up, on and on and on forever. Okay? And we call this graph a parabola.
Oh, that was this morning, right?
Yeah.
Why are they in the shower? Why is this gonna be the right here? That's gross. Who?
That's gotta be keeping.
Okay. So parabola is words you want to fill into the blanks there. Okay. So we can model relationships using quadratics. Okay. Bless you. So this table shows the baseball's height above the ground over time after it was hit. Okay. So also, boys baseball tryouts are Wednesdays. want to sign up? So what we're going to do is we're going to graph this, okay? Because if you watch baseball being hit, it goes up and then comes back down, right? Just like anything that gets thrown up to the air, okay? So what we're going to do is we're going to graph this data, and then we will say what the shape of the graph is, okay? So our time is going to be along the x-axis, and then our height will be along the y, okay? So over here we'll have height. And that is in meters. So put a little m there. And then time will be down here. And that's going to be in seconds. Okay, and then we're going up by half seconds. So, how many spaces do we have here? 1, 2. Okay, so I think it should work if we start our time at 0, and then we'll do every 2 boxes at 0.5, just so that it's nice and spaced out. So count 2 over, 0.5, count 2 over, we'll have 1.0 seconds, 2 over will be 1.5. If you wanted to do every individual box, you could, but I'm just going to do it this way just to make it like nice and spaced out for us. 2.0. 2.5, 3.0, 3.5 here, and 4.0. Okay, let me go. Okay. Now our graph, our y start at 1, go down to 0. But they have a peak around 138 meters. Okay, so what do you want to go up by each box on our y-axis? To go from 0 all the way up to 130 or 138. I think we have 15 squares that we can do. We do the little squiggle thing if everything was at like 100. But because we have, bless you, we have values going from 0 all the way up to 138. We have to make sure that we include everything in there. Okay? So I'm just going to go up by 10s. Okay? Because we have 15 boxes, we go up to 138. That'll take us all the way up to 150. So we'll be able to cover everything. So this one will be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. Okay? And then like Jose said, if everything was at like 110 to like 150, then you could do the squiggly line to show that there's a big gap there. But because we have to go all the way down to 0, we need to include all our numbers. Okay, so that's the first part of making our graph, and start with me title on the height of bases. Okay, so that's our first step to make our scales, and now we're going to plot every point. Okay, I'll do it in red, just have a different color. Okay, so at time 0, so we're looking at 0 on our x, we're at 1 meter. Okay, so our box goes from 0 to 10. So just make sure you put the dot kind of near the bottom. Okay, so it's just off of the x-axis to show that's not at 0 yet, but it's very close to it. Next, our y is 0.5, and we'll go up to 12.5. So go past 10, about a quarter of the way through the box. Maybe right about there. Okay, so we did the first 2 points. They don't have to be exact, but just make sure like you have 12.5 above 10 and below 20. Okay. Next, we go 1 second all the way up to 85. So follow the 1 all the way up. And here we have 80 and 90. So go halfway in between for 85. Let's check off that one. Okay. Then we have one, so at 1.5 seconds. At 1.5 seconds, we're at 130 meters. So go 1.5 all the way up to 130. And that one we can put right on the corner of the box. Now I'm going to be at 2 seconds, and we're going to go up to 138. So follow the 2 all the way up. So it won't quite be at the 140 line. I'll put it just, showed up there. I'll put it a little bit below. Okay, now we're at 2.5. Check that one off. Now 2.5. Follow it all the way up to 130 again. Check that one off. Now I can go 3 all the way to 85. So it should be about where that other one was. Then 3.5 and 12.5. So just go up a little bit past 10. Right there. And then 4 and 0. Put it right on the axis. Okay. And then the last step is just to connect everything. And go up like that, and then comes down. Looks like that. No. Okay. So you can see the ball will go up and then come back down. So then we see a pattern in the numbers too. So just kind of ignore this one at first. We'll go 12.5, 85, 130, 138, 130, 85, and 12.5. Perfect. So it's inclining, going up, and then coming back down. It's declining at the same rate, at the same numbers. Okay. So the shape. Describe the shape of the graph. If you just want to put it beside the graph, you can say that it increases or inclines. So increases. Until, what was it, 2 seconds is the max? Until 2.0138. Then decreases. Okay, so it increases until 2 and 138. Is everyone familiar with point notation? At this point right here would be 2.0 and 138. So you always write the x first and then the y and put in brackets to show what the point is. Okay, but yeah, it goes up and then comes back down. So parabolas can either start up, come down, and go back up, or they can start down here, go up, and then down. So it can either increase and decrease, or decrease and then increase back up. Okay. Is everyone from like okay with like graphing like that? You just take your x and you take your y, put them in. The hardest part would probably be getting a proper scale, but it doesn't matter. Like if you went 0.5, 1, 1.5, 2, it would just be like a little bit more compressed, which is fine. Actually, keep myself here a minute. Increase and decreases. C. What was the baseball's maximum height? So how high did the baseball reach? Was that? Perfect. So just look through your table values or look at your graph and look for the highest point. Okay, the highest point is right here, which is 138. So the max height was 138 meters. Okay. If you just put 138 meters, that's fine. But make sure you include the units, okay? And then kind of cut off by my axis there. But for how many seconds was the baseball in the air?
2 seconds.
So yeah, 4 seconds. So it took 2 seconds to reach the maximum height. So just look for when it hits 0 again, and it is at 4 seconds. So yeah, you can either look for the time when it's maximum and double it, or look for when it hits 0. Okay, so because the height is 0 at 4 seconds, that's how long it was in the air for. Okay. You're right, it would be a bit more than 4 seconds, but.
Well, we're going by what it says on the graph.
Go by what it says on the graph, exactly. So yeah, Tristan's technically right. If it was a natural equation, it would be a little bit more than 4 seconds because it's perfectly symmetrical. Okay? That's why if we're looking at the maximum here, if you go half a second over, it's at 130. If you go half a second over the other way, also 130. Okay? If you go a full second over, it's at 85. Go a full second over, it's at 85. Okay? So we'll see this. Parabolas are perfectly symmetrical. Okay, it's one of like the key points of them. So we'll talk about the axis of symmetry in a minute. Okay, you can kind of see this half looks almost the same as this half. Okay, does everyone have the graph drawn? I erase it. Good. Okay, so we want to graph the relation y equals x squared. So the most basic equation for a quadratic equation is just y equals x squared. Okay? Forget the a, forget the h and the k. If we kind of just break it down to its most simplest form, it's just going to be y equals x squared. Okay, so let's see what that looks like. Okay, so I gave you the first point that we're going to use right in the middle. Yep, go ahead. It is 0, 0. Okay, because if we were to sub in y equals our x value, which is 0. Squared, what's 0 squared? 0 times 0 would just be 0. Okay? So our first point is going to be right there at the origin, 0, 0. What we're going to do next is we're going to go 1 over to the left and 1 over to the right. So if I move 1 to the left, what number is this? Perfect. -1. So I'll go -1. It's going to be my next x value. Okay, so over here, I'm going to go y equals x squared. But instead of my x, I'm going to use x equals -1. Okay, so I'm going to sub in -1 for my x. Okay, and then you can try it on your calculator. But -1 squared, that's going to be -1 times -1. And what's negative times a negative? It's going to be positive. And then what's 1 times 1? Just perfect, just 1. So when x is -1, y will be +1. Okay, so then at -1, I'll go up to +1 and do a dot. So 1 to the left, now I want to move 1 to the right. And 1 to the right would just be +1. Okay, so now I'll try x is +1. So I go y equals x squared, but now my x is 1. So I'll sub in 1. And then what's 1 squared? Nope, so it'll be positive times positive, which is +1. Okay, so this one is +1, +1. So we'll go x is +1, y +1, and there's my dot right there. Now, from -1, I'm going to move 1 more to the left. I'll go to -2. Okay, so I'm going to try x is -2. So I'm going to sub it into my equation again. Y equals x squared, but what's my x this time? -2 exactly. So then what would -2 squared be? It would be -2 times -2, which 2 times 2 is? +4. +4, good. Because they're both negative, 2 negatives become positive when we multiply. -2, +4. Okay, so I'll go to x -2 up to +4. Good point right there. Last one I want to check is if I go 2 to the right. So I'll go -1. Now I'll do x is +2. So I have y equals +2 squared. And then what's 2 squared? 4, perfect. 2 squared would be 4. So my y will be 4. So it goes to +2 and up to +4. Okay. And then there's not enough room in the table, but if we did one more, you could go to -3 and it would be +9 and +3 and negative. Okay. And then we just connect the dots. Okay, so that is y equals x squared. Okay, so that's the most basic parabola that we have. Just goes down and then comes back up. Okay, and it touches the x-axis at the origin at 0. Okay, so we'll talk about like rules when we start graphing, but what we do is we start at down here, what we call the vertex. Then we go over 1, up 1, over 1, up 3 more, over 1, up 7. No, 6. Okay. Yep. Okay. Yeah. So there's gonna be a lot of writing on the next chart. I apologize, but that will probably be where we wrap it up for today. Kind of ease back in the school after March break. Okay. Lots of writing. So in that chart, we'll go through it box by box. So for if you ask what's the direction of the opening of a parabola, just say whether it goes up or it goes down. So if I was looking back at y equals x squared, the opening is up. Okay, so that's why it's up. The other way you can think of it as when it's up, it almost looks like a U for up. Okay? If it went the other way, I'll do it. U is P for up. If it were to open up the other way, it's facing down, and that almost looks like a big S. So it opens down. Okay, so U, the opening is up. Go the other way, it's opening down. Okay, so in the middle, I'm going to write the definition, then I'll say what it is for y equals x squared. Okay, so vertex, that's a turning point of the parabola. Okay? So what I mean by turning point is when it comes down, it stops at 0, 0, and then goes back up. So what's going down and then goes up. That's where it turns. For this one here, it's going up and then it stops here and goes down. Okay? So it's either going to be like, yeah, maximum minutes next. Don't worry. This is what we're going to finish with for today. Okay? So it's either the highest point or the lowest point. Okay? If it's going up, it's going to have the lowest point down here because these go up to infinity. If it's going down, it has a maximum point there. Okay? And so the maximum or minimum always occurs at the vertex where it turns around. Okay? Just put that the vertex point is HK. We'll talk about that a little bit more. Not tomorrow. Actually, yes, tomorrow. No, not tomorrow. The day after now. When we talk about it in relation to the vertex form of quadratics, okay? So our vertex for y equals x squared was at 0, 0. Hey, bud. Trade check. Okay. So started way up, came down to the origin 0, 0, and went back up. Okay? So the minimum value is always going to be the y value. Okay? It's going to be the y value of your vertex. Okay? So you can always look at the vertex and see where it is, and then look at the way it's opening, and that'll be either the maximum or the minimum, but that value will always be the y portion of the vertex. Okay, the axis of symmetry, that's the line that kind of cuts the parabola in half. So it's an equation of a line, x equals something because it's a vertical line, but it's always going to act like a mirror. So when we did the baseball one, the left side kind of looked the same as the right side. If you just kind of cut it down the middle, all the points were the same. That's going to be this axis of symmetry, okay? So all parabolas are symmetrical like that. If you were to put a mirror down the middle, it would look the same on either side. And the axis of symmetry is always the x value of your vertex. Okay? So wherever your vertex is, just take the x value of that, and that is the axis of symmetry. Okay. All right, so we'll take up the rest of them now. So we did A and B. All there. So for C and D, does C open up or down? Up. Good. And what was our vertex? The point that's right here. Brought around a lot. You got it. Perfect. -3 and -3. So we're going to use these values for our min and max and, bless you, our equation. Do we have a minimum or a maximum value? Perfect. We have a minimum since it's going up, and that minimum would be -3 because of the y value of the vertex. Equation of the axis of symmetry. X equals 3 or -3?
-3.
Perfect. -3. Because it cuts it down right in half, right at the vertex. Okay. X-intercepts, we have 2 of them. So don't want you just write that there's 2. I want you to write like what they are. This one isn't perfect because I should have it moved down one more. But just write the numbers that are closest to it. -5 and say -1 for the 2 numbers that are closest to. So if you do that, that's fine. If you do like 4.5 and 1.5, that's fine too. Okay. D. A lot of people just mess up the one part on this one. So does it open up or down?
Yeah.
Good. It's facing down. And what is the vertex? 1 and good. So remember, the horizontal is our x, and the vertical is our y. It hasn't moved up or down, so that's why our y is still 0, but it's gone 1 over on the x. So we have x then y, so it's 1 and 0. A lot of people are putting 0 then 1, so just make sure if you made that mistake, just do 1, 0. Okay? This time, do we have a minimum or maximum? Maximum, good, because it's upside down, so we have max of, and what would the max be? Be careful. Yeah, 0. Good. Because we're taking from the y. Okay? So if you had the 0 and the 1 flipped, just make sure you flip back your max and your axis of symmetry. Because the axis of symmetry would be x equals 1. Right down that way. Okay? So if you have to flip your vertex, just make sure you flip these guys as well. Okay? And then how many x-intercepts do we have? Yep, perfect. We just have 1, so it goes up. It kind of touches the x-intercept and then comes back down. So we just have 1, and it's actually at 1. Okay? So our x-intercept is just at 1. Okay, E and F. E, is it going up and down? Or up or down? Down, good. So E goes down, and where is our vertex on E? Perfect, 0, -3. Because it hasn't gone anywhere left or right, but it's gone down 3. So again, it's going down, so that means that we have a minimum or a maximum. Good, we have a maximum. Because it comes up to the peak and then it comes back down. And our maximum would be -3, perfect. Our y coordinate. Okay, equation of the axis of symmetry. What would our x value be for the equation of the axis of symmetry? 0, perfect. The x coordinate. And then how many x-intercepts do we have? None, perfect, because it never actually crosses that horizontal line. It just comes up, tries to pass it, but then can't. So we have none. Okay? I'd rather put like none or nothing rather than just 0, because it's kind of saying like the x-intercept is at 0. So let's put none. Okay, F, we actually will have some x-intercepts. First, does it open up or down? Up, good. Facing up. And our vertex is right here, which would be what point? Yep, -4, and what's the x part of it? 2, good. It's gone over 2, and then down 4. So do we have a minimum or maximum? Do you have a question, bud?
Minimum is -4.
Yeah, go ahead, buddy. Minimum of -4, good. And what would the equation be? X equals 2. Perfect. And now for the x-intercept, just look to see where it crosses over. So where does it cross the x-axis at? We have 2 points.
-2 and 6.
Perfect. -2 right there, and then onto the. So yeah, -2 and 6. Right. Last 2, then we're done early for today. G, is it going up or down? Down, good. And where's our vertex? Vertex would be
0 and 3.
perfect. 0 and 3. So because it's going down, that means we have a maximum. And the max would be at 3. Good. Equation of the axis of symmetry would be at x equals 0. Good. Now we have two x-intercepts again. They're going to be at, if you can't tell on your sheet, it's hard to read, they're at -3 and +3. Okay, last one, H. Are we going up or down? Up, good. Where is our vertex? Little turning point there. Go to the x, goes over to -3. And then our y is at -1. Okay, so because it's going up, we have a minimum. So our minimum will be -1. Very good. So it's a y. Our axis of symmetry would be x equals -3. Perfect. And then we'll have another 2 intercepts at -4 and -2.